In this lesson, we'll be discussing equations as relations. At the end of the lesson, you should be able to use an equation to determine the range for a given domain and determine the solution set for a given domain. So an equation relation is when the equation has two unknown values, so the two variables are ordered pairs x and y, and the equation describes that relationship. For example, y equals 2x. The solution set just means that the ordered pairs make the statement true. So if they work and it does equal, it's a solution. Answers are shown as a set, and they are becoming braces. The domain is an independent variable, so that means it doesn't change depending on something else. And I highlighted the I in domain and the I in independent just to try to remember that those two go together. The domain is the x values, or the first letter alphabetically if they use different letters like M and N. Typically, time is the independent variable. It can also be written as f of 4, which simply means that x is 4. When we write the domain, you write it from least to greatest with no repeating numbers. The range of the dependent variables means it's dependent on something else. These are the y values, or the second letter alphabetically. Quantity is typically the dependent. The y, or the range, can also be written as f of x, and again, written from least to greatest with no repeats. So for example, studying the table and finding the missing y values, the x is going up by 1, and the y is 3, 6, 9, so the next value would be 12, and the next one would be 15. So explaining the pattern, the x value is multiplied by 3. An equation, y equals 3x. It says find the solution set for y equals 2x plus 3 for the replacement set of those ordered pairs, which means I'm going to take these values for x and y, -2 and -1, and place those in the equation and determine if that statement is true or false, and it is true. I take the next set ordered pair in the replacement set, put them in the equation, and that's a false statement. Take the third set, write it in the equation, and it is a false statement. I take the last one, put in the x and y values, and that is a true statement. So my solution domain, the x values that work in this equation are -2 and 3, and my range numbers, the y values that work in this equation. Find the range for the given domain. So we're given this equation 4x plus 2y equals 10. So if we plug in x, it would be much easier to solve this if I change that equation around, subtract 4x from both sides, and divide everything by 2 to get the equation y equals 5 minus 2x. Then I can plug in -1 for the x. I find that the y is 7, so my ordered pair is -1, 7. If I plug in the domain of 0, use that in my equation, the y value is 5, so my ordered pair. Plug in 2, rewrite the equation, and find my ordered pair. Plug in the last one for the domain, my y is -3, and I have my ordered pair. So there's my domain and my range. Notice they're written in order from least to greatest and no repeats. All right, find the range for the given domain of y equals the absolute value of x minus 2. I'll plug in that x number, write it in the equation, and find the y. Remember, absolute value means the distance from 0, and so it's always going to be a positive number. There's my ordered pair. Putting in 2, getting 0 for y. 3 is my x value. My y then becomes 1, my ordered pair, and my last one. So my domain all of the x values that I was given, and then my range, remember writing them in order from least to greatest and no repeats. So even though the 1 is here and here, I don't write the 1 twice. Now I need to write a function rule. So 8 less than 1/3 of x is y. I write it like that. Y equals 1/3 x minus 8. 12 more than the quotient of a number t and 7 is v. The price of a large cheese pizza is $7.95 plus 75 cents for each topping. So it's 75 cents per topping plus the $7.95 for the pizza. Eric is 2 years younger than 2 times his sister's age. Write a rule that represents Eric's age, A, as a function of his sister's age, S. So see how they use different letters than X and Y. So there's the equation, and then how old is Eric if his sister is 11 and he is 20. So the domain and our range, the range is our Y values, the domains are X values, the domain is independent, the range is dependent, time is on the X, and quantity is on the Y. Is the dependent variable on the X or Y axis? The dependent is the range, which is on the Y. Independent is the domain on the X.